Hello, guys. Welcome to Ramta Solutions and welcome to your physical sciences exam prep on momentum and impulse. The question that we are looking at today is from the Gauteng Province, September 2024 Physical Sciences Physics paper. Okay, of 2024, by the way. So, as is a norm, when we check our past papers, we read instructions. Remember, all of them are important, but I'm going to read just a few that we might use in this segment. So let's see. Instruction 5. In case you forget your formulas, you are advised to use the attached data sheets. Not all of them are given, but most are given. All right? Yeah, most are. In fact, 90% of them are given here, or even 99. Okay? Then Instruction 9, show all formulae and substitutions in our calculations. Instruction 10, round off your final numerical answers to a minimum of 2 decimal places. Now, further on this, in the middle of your calculations, if you were to get decimals, please round them off to maybe 4 or 5 decimal places. If you don't mind writing all 10, 15 decimal places, but we advise 5 to, 4 to 5 decimal places, one head. Okay, and then your final answer, write it to 2 decimal places. Instruction 11, give brief motivations, discussions, and so on where required. Okay, this does not mean that you shouldn't give motivations. Give motivations as long as they make sense, but try to be brief. Don't write an essay on a problem. Okay. Okay, and then instruction 12. A lot of us are struggling with that. Instruction 12, write neatly and legibly. Please, let's try to improve our handwriting, guys. It's important that we do, eh? It's important that we improve our handwritings. While we work on our understanding of the theories and concepts, let's also work on our handwriting. It's very key that we focus on that. Okay? And by the way, that says someone who also says, hey, I don't like my handwriting. Right? All right, let's go. Normally momentum is question 4 because question 2 is forces, 3 is vertical projectile motion, and then 4 could be momentum. Okay, perfect. Maybe let me zoom it. Okay, perfect. As you can see, this is 13 marks. We need to spend 13 minutes. So let's see. Oops. Question 4. The wooden block of mass 150 grams is freely supported. Okay, is freely supported. So mass 1 is 150 grams, which is dividing by 1000 is 0.15 kilograms. Okay, it's freely supported on brackets at a height of 2 meters. When a bullet of mass 50 kilograms, 50 grams, mass 2 will be 50 grams. So dividing this by 1000 you get 0.05 kilograms. Okay, cool. So this one, they say it's freely supported. So it means its initial velocity is 0. Okay, it means its initial velocity is 0. Okay. When a bullet of mass 50 kilograms is fired vertically into the block as shown below. Okay, so I see we are given the initial velocity of the block. It is 200 meters per second upwards. All right, 200 meters per second upwards. Right. Okay, cool. So let's see now. The bullet embeds itself into the block and the bullet block system rises vertically into the air for a few seconds and then falls back to its original position. Cool. 4.1. State the law of conservation of momentum inwards. In an isolated system, total linear momentum is conserved. In an isolated system, total linear, okay, total linear momentum is conserved, okay, is conserved. So when you say you are slow, you must spend 13 minutes on this question, but you might even spend way less than 13, okay? Remember, 1 mark, 1 minute. Calculate the magnitude of the velocity of the bullet block system after the bullet becomes embedded on it. So this will be mass 1, velocity 1 initial plus mass. But before we do that, let's say this. We're going to say upwards is positive. Remember, momentum is a vector. So momentum calculations are vector calculations. So let's go. Mass 1, initial velocity of object 1 plus mass 2, initial velocity of object 2 equals mass 1 plus mass 2 times final velocity. Remember, they were embedded, right? The bullet was embedded into the block. Okay, so what is the initial velocity of, we said 1 is the block, so it is 0,15. Its initial velocity was 0. And the bullet was 0,05. Its initial velocity was 200 meters upwards. Now finally, it is 0.15 plus 0.05. We do not know what the final velocity was. Calculate the magnitude of the velocity of the bullet block system after the bullet becomes embedded in it. Okay, so what is this? 5 times 2 is 10. So 10, it'll be 0,10. Yeah, it'll be 0, hold on. Yeah. So 5 times 200. Yeah, 5 times 200 will be 1000. So it'll not, 1000. So this will be 10, because we'll have 2 decimals, and this will become 0.20 V sub F. Now, 10 divided by 0.2 must be 50. So V sub F is 50 meters per second. I'm not going to write the direction, guys, because they said the magnitude. So this is 50 meters per second. They said magnitude. So the direction is not important. Okay? Perfect. 4.3 is the collision between the bullet and the block an elastic or elastic collision? Explain by using a calculation to justify your answer. Our calculation, E sub k equals half mv squared. So now we're going to look for EK. So what we need EK total, okay, before the collision. So let me do this. So sum of it, initial, okay, initial will be, what did we have? Half the mass was 0.15, velocity or speed was 0, and half the mass was 0.05, and the speed was 200 squared, isn't it? So what is this? 0,05 times 0,5 times 200 squared must be, so what is our answer? We get 1000 joules, isn't it? We get 1000 joules. So this is the total kinetic energy before collision. Now let's look at the total kinetic energy after collision. What is this? It is half. What was the mass? It was 0.15 plus 0.05. What was the final velocity? Our final speed was 50, right? So let's see. 0.5 times 0.2 times 50 squared. What is our answer? 250 joules. As you can see, sum of total kinetic energy before collision is not equal to total kinetic energy after collision. All right, after collision. Therefore, collision is, how is the collision? Inelastic. Right? Collision is inelastic. Remember, inelastic collision, total kinetic energy before collision is not equal to total kinetic energy after collision. Okay, perfect. 4.4. On a different occasion, a bullet is fired closer to the wooden block at the same velocity, and it exits the block with an upward velocity of 195 meters per second. Okay, 195 meters per second. If the net force exerted on the block is 5 newtons downwards, calculate the time it takes the bullet to exit this. Okay, so what are we going to say? Again, these are vector calculations. When there's a force involved, you need to state which direction you want to be positive. So I'm choosing upward being positive. So we're going to use the formula, momentum impulse theorem, right? It's in your formula sheet. It's given as F net delta T equals delta P. Okay, so what I want to do, I want to extend this and say this is M final velocity minus initial velocity. Okay, so let's read this question. It says it exits with an upward force of 195, so it means it's positive, but the direction of the force, they said it's downwards, so it's going to be -5, and the time we do not know. What is the mass of the object? The bullet, rather, it was 0.05. What is the final velocity? It's 195 upwards, so it's going to be positive. The initial velocity was 200 meters upwards, right? Perfect. So now delta T will be, maybe let me not do this. Let me just say 5 delta T equals, -5 delta T equals 0.05 into -5 close. What is this? This is -0.25, right? Right? This is -0.25, isn't it? -0.25 dividing by -5, this then becomes 0.05 seconds. Okay, and this is the time it takes the bullet to exit the block. So you see, with our yada yadding, we were able to finish this question on time. All right. So with that being said, remember guys, if you're looking for a tutor, you can visit our website. But before looking for a tutor, you can subscribe, follow us on your favorite social media platforms. The links are given in the description of this video. And of course, if you enjoyed this video, you can subscribe, like, and share with your friends. So with that being said, it's a wrap, and bye bye.